All right, ladies and gentlemen, so here is solving radical equations day 2. So the same essential questions, same learning goals, just the problems are going to look a little different. So here we go. All right, so here's example 4, and hopefully you realize it does say to solve the equation. Don't forget to check for extraneous solutions. All right, so here is the difference. Instead of having it as a radical form, like we did yesterday, this has the power over root. So we still know that our root is the denominator. So the first thing I like to do is go ahead and rewrite this as the cube root, because our root is 3, of 2x plus 1. And then we have this plus 5 outside of that radical equals 0. So basically what that means is we're still going to do the same steps as yesterday, only now the problem, we just got to know that writing it this way and this way is the exact same thing. All right, so our goal is to get the radical all by itself, even though it's a cube root. We're going to get that radical by itself. So how do we do that? We're going to subtract 5 to each side. Whatever you do to one side, you got to do to the other side. And so when we do that, we still have our cube root and whatever is written inside of that radical, 2x plus 1 equals negative 5. And so here's where it's a little different from yesterday. Yesterday, we only worked with square roots. Well, we have a cube root, so instead of taking each side to the second power, we need to cube each side. So whatever your index is here, you got to take it to that power. And remember, whatever you do to one side, you must do to the other side. So hopefully you remember yesterday when we had a negative inside and then we squared it, sometimes that caused extraneous solutions. So let's see this one. What if we cube it? Will it be extraneous? Let's figure that out. 2x plus 1 is going to equal, and so remember you're doing negative 5 times negative 5 times negative 5. And I just know that's negative 125. All right. So whenever we cube each side, that's how it gets rid of that radical. This cancels that out, and we're left with just a 2x plus 1. Now we're going to use box and wall and solve like normal. So we're going to subtract 1. I'm going to have to start writing really small here. So 2x equals negative 126. Divide by 2. So x is going to equal to negative 63. This is called short division. 2 divides into 12 6 times. 2 divides into 6 3 times, so it's 63. Now we got to check. Hey, I know yesterday when we squared a negative, it caused us to have extraneous solutions. What if it was cubed? What happens? So we need to check our answer. So I'm going to go ahead and rewrite it. I'm going to go ahead and use this equation. So I'm going to write cube root. I'm going to put 2 parentheses plus 1 plus 5 equals 0. So we need all of this to equal 0. And I just went ahead and put a blank spot where the x is. I know this is being multiplied, so that's why I use parentheses. I'm going to plug in negative 63. Remember, you can do this step in your head. All right, so we're going to have the cube root. Well, we already know that negative 63 times 2 is negative 126 because we divided it and got 63. Then we're going to add 1, and then add 5 outside equals 0. We know that's going to be the cube root of negative 125. And then we're going to add 5 equals 0. And so, yes, the cube root of negative 125 we know is just negative 5. I can't write over there, so I'm going to go here. It's just negative 5. So this whole thing right here became negative 5. And then we're going to add 5, and that is 0. So 0 equals 0. Bam, we know this is okay. So here's the kicker. If this is odd power, it does not cause extraneous solutions. But if the base is a negative and we have an even power, that's when we need to make sure we really check for extraneous solutions. All right, one more example, and then we're good for today. It's already in radical form, so we're just going to go ahead. First step is to go ahead and get the radical all by itself. So we need to move that 4. I'm going to add 4 to each side. I'm going to write smaller today. There we go. So we have the fourth root, just bring that down, of 3x plus 1 equals 3, because 4 minus 1 is 3. Now, since our index is 4, we're going to raise it to the 4th power each side. So that's fourth root and the 4, they cancel each other out. So we have 3x plus 1 equals, this is where you got to be careful. What's 3 times 3 times 3 times 3? That is just 81. And then we're going to box and wall, get that all by itself like we normally solve for algebra. Subtract 1. So we're going to have 3x equals 80. Divide by 3. Divide by 3. So x equals 80 over 3. Yes, sometimes we have fraction answers. I shouldn't box it just yet because we're not sure. It might be an extraneous solution. I'm not predicting so because this is a positive 3 and then we did to the 4th power, but you always want to double check. So I'm just going to rewrite this, but instead of x, I'm going to put a 3. So 4th root 3, all of that, plus 1 minus 4 equals negative 1. So basically this left side needs to be negative 1. All right, so we're going to plug in our answer, 80 over 3. Well, that's nice. 80 over 3 times 3, those 3's cancel, so it's just 80. And then we know this whole thing is just going to be 80 plus 1. I'm going to go ahead and write it. 80 plus 1 minus 4 equals negative 1. And so we're doing the 4th root of 81 minus 4 equals negative 1. And we know the 4th root of 81 is just 3. That's kind of how we got it to begin with. And is 3 minus 4 negative 1? It sure is, so we know, without a doubt, that is our answer. All right, hopefully this video helps you out. Make sure you let me know if you need help with anything else. Thanks for watching. See you guys later.